Does the universe have edges? Have you ever wondered if there's a limit, a border, or if it simply stretches out into infinity? In this video, we're diving into the deepest mysteries of the cosmos and exploring concepts that challenge everything we know. Is the universe finite or infinite? Does it have edges, shapes, or dimensions we can't even begin to imagine? By watching until the end, you'll gain a clearer understanding of the most fascinating theories about the universe, from the limits of physics to the groundbreaking ideas of modern science, and more. You'll discover how these findings directly impact our perception of reality. The universe is such a vast concept that even the brightest minds in human history struggle to fully comprehend it. Let's begin with what we do know: the observable universe. This region is limited by the distance light has traveled since the Big Bang, around 13.8 billion years ago. Estimates suggest the diameter of the observable universe is roughly 93 billion light-years, an unimaginable expanse for anyone. But that's just the beginning. What we see is only a fraction of the whole. Galaxies, stars, and clusters stretch out like points of light into infinity. But what lies beyond? Could there be something outside this observable sphere? Theories suggest the universe may be far, larger, possibly even infinite. But our technology and the very speed of light itself limit our ability to see further. To complicate matters even more, space isn't static. It's constantly expanding, pushing galaxies further and further apart. This expansion, discovered by Edwin Hubble in the last century, means that the universe we observe today is merely a snapshot of the past. Every point of light we see in the night sky carries a fragment of cosmic history. But here's an intriguing question. If the universe is expanding, where is it expanding to? This leads us to think about limits, or the lack of them. It's possible that the universe is like a boundaryless surface, such as an inflated balloon, but in 4 dimensions. And if that's the case, does it have edges? One of the biggest questions in modern cosmology is, what is the shape of the universe? Scientists have debated for decades whether the universe is flat, curved, or something far more complex. The idea of edges, or borders, is closely tied to this question because the shape of the universe determines how it might extend or not. Based on measurements of the cosmic microwave background radiation, the light left over from the Big Bang, data suggests that the universe is nearly flat. This means that, on gigantic scales, it doesn't appear to curve upward or downward. Yet, even so, it could still be finite and have a closed structure like the surface of a sphere. In that case, if you could travel endlessly through the universe, you might eventually end up back where you started. On the other hand, if the universe is infinite and flat, it stretches without limits, like an endless sheet of paper. This brings up an even more thought-provoking idea. What does infinite really mean? The concept goes beyond what we can imagine, but is essential to understanding the structure of the cosmos. If the universe is infinite, it has no sides, edges, or boundaries. But there's a third possibility that challenges our perception. The universe might be hyperbolically curved, resembling a saddle. In this case, it would still be infinite, but with a geometry that seems stretched at its edges. This suggests that space could behave in ways that defy our intuition, leaving much yet to be explored. Regardless of its shape, scientists agree on something fascinating. The answer is encoded in the very structure of space-time. Gravity, dark matter, and dark energy play fundamental roles in shaping the universe. The quest to unravel this mystery is one of the greatest challenges in modern physics. At the heart of the universe's mystery lies a phenomenon that defies our understanding: dark energy. Discovered in the late 20th century, dark energy is responsible for accelerating the universe's expansion. But what does this mean for the idea of sides, edges, or boundaries? The cosmic expansion suggests that the universe, whether finite or infinite, is constantly growing. But in what direction? Imagine an invisible force acting against gravity, pushing galaxies apart and stretching space itself. As counterintuitive as it seems, dark energy not only influences how the universe expands, but could also determine how it ends. Depending on its intensity, dark energy could lead to a future where the universe tears itself apart, a scenario known as the Big Rip. But what about the edges in this expansion? Science hasn't reached a consensus yet, but if the universe is infinite, it will continue expanding endlessly. If it's finite, this growth could cause its edges, if they exist, to move farther and farther away. This creates the notion of a limit that's always out of reach, an unattainable frontier. If expansion continues at different rates in certain regions of the cosmos, it's possible that cosmic bubbles or parallel universes could form. In this case, our universe would be just one piece of a much larger puzzle. Each side or limit could serve as a doorway to an entirely different reality. The study of dark energy seeks not only to understand how the universe grows, but also what this growth means for its overall structure. The more we discover, the more we realize that our concepts of space and time might be mere fragments of something far more complex. If the universe has sides, this raises an even more fascinating question. What lies beyond those edges? Enter the theory of multiverses, a revolutionary idea suggesting that our universe could be just one among many. Imagine an infinite collection of cosmic bubbles, each with its own laws of physics, constants, and forms of existence. One of the most popular hypotheses is the inflationary multiverse theory, proposed by Alan Guth. According to this idea, during the Big Bang, the initial expansion was so violent that it created multiple universes, each with its own unique space-time. Every side of our universe could, in theory, connect to another parallel universe. But how can this be proven? For now, the idea resides in the realm of theoretical physics and speculation, but evidence could emerge as science advances. Another possibility is the quantum multiverse, tied to quantum mechanics. According to this theory, every time a decision is made or a particle chooses a state, new universes form to accommodate each possibility. This creates an unimaginable number of universes where all realities coexist. In this scenario, the sides of the universe are no longer physical but instead parallel and overlapping dimensions invisible to our senses. Even more intriguing is the idea that our universe might exist within another universe. Some scientists suggest that black holes could act as portals to new universes. When something crosses the event horizon of a black hole, it might be transported into an entirely new cosmos. In this case, the sides of our universe would be the boundaries between realities, layers of a multiverse in constant creation. Although fascinating, the idea of multiverses raises profound philosophical questions. If infinite universes exist, what does that mean for our existence? Are we in a special cosmos, or are we just one among infinite possibilities? This is a mystery that continues to challenge our understanding. While we live in a universe we perceive as three-dimensional, with length, width, and height, modern physics suggests that there may be much more beyond these dimensions. String theory, one of the most advanced frameworks attempting to unify gravity with quantum mechanics, proposes that the universe could contain up to 11 dimensions. These extra dimensions would be invisible to us but play a crucial role in shaping the cosmos. Imagine the universe as a sheet of paper. To an insect trapped on that sheet, the world appears to be only two-dimensional. But if it could jump off the paper, it would realize a three-dimensional space exists. Similarly, these hidden dimensions might surround us, but they're so folded that we simply cannot access them. This concept, suggested by scientists like Theodore Kaluza and Oscar Klein, continues to be explored in more complex theories. How do these dimensions connect with the idea of sides of the universe? If additional dimensions exist, the boundaries we perceive may only be reflections of something larger. For instance, one side of a three-dimensional universe could be just a projection of a higher dimensional space. These extra dimensions might also be where mysterious forces like gravity and dark energy act most intensely. Some of these ideas become even more fascinating when we think about black holes. They may act as gateways to these hidden dimensions. String theory suggests that black holes could contain information about these extra dimensions, and studying their radiation, such as the emission at the event horizon, could offer us clues about these hidden realities. Extra dimensions could also explain mysteries we still don't fully understand, like dark matter. Perhaps dark matter isn't made up of particles, as we've thought, but is instead the result of interactions occurring in dimensions we cannot access. This would mean we're surrounded by a part of the universe that remains hidden, yet is essential to the existence of everything we know. The event horizon is one of the most intriguing concepts in astrophysics. It's the boundary of a black hole, the point where gravity is so intense that not even light can escape. For many scientists, it represents one of the universe's most enigmatic limits, a place where the laws of physics as we know them cease to function. But what truly exists beyond this boundary? When something crosses the event horizon, it disappears from our view, but that doesn't mean it ceases to exist. Theories suggest that matter and energy pass through this barrier into an unknown region, where space and time may behave in entirely different ways. Some cosmologists believe that the interior of a black hole might serve as a portal to other parts of the universe, or even to other universes. The idea of sides in the context of the event horizon is particularly fascinating. To an external observer, it seems as though anything approaching the black hole slows down infinitely as it nears the horizon. This creates the illusion that the event horizon is an impenetrable barrier. However, for someone falling into the black hole, time and space distort so dramatically that it might feel like crossing over to another side of reality. Stephen Hawking introduced a groundbreaking perspective by suggesting that black holes can emit radiation, known as Hawking radiation. This means that black holes could evaporate over time. But what happens to the information contained within them? This question lies at the heart of the information paradox, a problem that challenges the very foundations of modern physics and could be directly tied to the structure of the universe as a whole. Studying the event horizon is like trying to uncover one of the deepest secrets of the cosmos. It shows us that the boundaries, or sides, of the universe are far more complex than we can imagine, challenging our understanding of space, time, and existence. If the universe has sides or edges, they might be connected to its end. But what does end mean in the context of the cosmos? Scientists have explored various scenarios for the universe's ultimate fate, each one more fascinating and challenging than the last. These scenarios are closely tied to the forces that govern the cosmos, such as gravity, dark energy, and the density of matter. One of the most discussed scenarios is the Big Freeze, also known as heat death. In this case, dark energy would continue to expand the universe indefinitely, pushing all galaxies so far apart that the cosmos would become a cold and empty place. Without heat, motion, or light, the universe would reach a state of maximum entropy. In this scenario, there would be no sides or edges, just an infinite void with no perceptible boundaries. Another possibility is the Big Crunch, the opposite of the Big Freeze. If gravity were to overpower dark energy, the universe could stop expanding and begin collapsing in on itself. In this scenario, all galaxies, stars, and planets would be pulled into a single point, similar to the state of the universe at the moment of the Big Bang. This end might actually be a new beginning, where the universe is reborn in a new cycle. In this case, the final side would also be the start of something entirely new. The most extreme scenario, the Big Rip, suggests that dark energy could accelerate the universe's expansion to such an extent that even atoms would be torn apart. In this case, space and time as we know them would cease to exist. There would be no sides, edges, or anything identifiable, only the complete dissolution of the cosmos's structure. There are also more speculative theories, such as the possibility that the universe might disintegrate into a series of multiverses, where new realities emerge as ours fades away. If the universe has sides, they might serve as portals to these other worlds, part of a continuous cycle of creation and destruction. These scenarios lead to profound reflections. What happens at the limit of the universe? Does a true limit even exist, or is the idea of an end merely a projection of our finite perception? These questions continue to inspire scientists, philosophers, and dreamers alike. Despite centuries of scientific advancements, the truth is that our understanding of the universe is limited by our own perception and technology. The idea that the universe may have sides, edges, or boundaries is shaped by the tools we use to observe it and the theories we construct based on available data. But are we truly prepared to comprehend something so vast? For instance, our senses can only perceive a fraction of what exists. We cannot see the radio waves that traverse space. We cannot feel the dark matter that makes up 27% of the cosmos. And we cannot perceive the hidden dimensions suggested by theoretical physics. To truly explore the sides of the universe, we would need to overcome the limitations of our biology and develop technologies far beyond what we have today. Philosophy also plays a role here. Many argue that the universe's boundaries might be a construct of the human mind. Our brains are wired to seek patterns and impose limits, even on something as vast as the cosmos. Does the idea of a side or end make sense in a universe that might be infinite? Or are we merely applying finite concepts to something that cannot be understood so simply? However, it's important to remember that every scientific breakthrough has brought us closer to unraveling these mysteries. The James Webb Telescope, for example, is already exploring the early days of the universe with unprecedented detail. Quantum physics and string theory continue to challenge our understanding of space and time, hinting that there is far more to discover than we can currently imagine. In the end, the quest for answers about the sides of the universe is not just an exploration of the cosmos. It's an exploration of ourselves. The more we strive to understand the infinite, the more we realize how much there is left to learn. The universe is perhaps the greatest mirror of our limitations, but also the greatest motivation to surpass them. And so, we end this journey through the mysteries of the cosmos. Does the universe have sides? Perhaps it does, or perhaps it doesn't. But what truly matters is that the search for this answer pushes us to expand our horizons, challenge what we know, and explore the unknown. After all, as Carl Sagan once said, somewhere, something incredible is waiting to be discovered.